In my previous lecture, we did talk about the statistical approaches, and one of them was estimation that we are going to explain a little bit more. Estimation is something that also we do in the normal routine life a lot. For example, in this conversation, she asks what time you will be there, and he replies that, for example, between 9 and 9:30. So in this case, there is a interval between 9 and 9:30 that the possibility that he will be there. So this interval also can be a level of the assurance or confidence here. If she asks, "Are you sure at between 9 and 9:30?" and he may say 95%, "I'm sure." In this case, it means that there's 5% possibility that he come earlier or later in this period, which is a small possibility also. Uh, we can see that in this estimation that is doing, they are using an interval and also a level of confidence. This is why also in a statistic we like to call 95% uh, confidence interval. Confidence interval. It means that we are 95% secure or sure about that being to doing something in a interval. And if this interval, for example, become 8 to 11, it will be much wider interval. So we cannot sure that when this person will come, this 95% confidence interval between 8 and 11, it will be very wide, and the estimating time of the arrival will be very difficult. So maybe we cannot trust such a wide interval. In a statistic, when we are thinking about the population and sample, we are gathering data through the sample. And the data that we are gathering supposed to be used later for the population. And we want to use those data as our best estimate of what is true for the relevant population. In this example, we have a sample of the 316 people, and you measured a variable, let's say something from the blood, at the continuous variable, and we measured the mean, which is 0.83, is the mean in the sample. Every data here is from the sample. And also based on the mean, we also can calculate the variance and a standard deviation based on the assumption for the normal distribution, the mean and the standard deviations. From the previous lectures, you can review those. And the question is, what can we infer or take the conclusion out about the same value in population? Or, as I wrote here, how good is the mean of the single sample as an estimate of the population value? There are a lot of statistical calculation here that it's not necessarily we go through them. We just explaining the final results and how we can do it. Well, we can use this statistic, and we are calculating a factor called the standard error to be able to go further about the estimation, how estimation, how good estimation is. The standard error is explained as the standard deviation divided by the square root of the sample size that we can get out of all of them from the data that we have here. The standard deviation, ST, or the little sigma that we have here, is 0.46, and the sample size is 316, that the square root will be calculated, and we reach to a value of the standard error. They said that the standard error itself may not be a something that we are reporting, especially when we are doing it for the mean, as we have here a standard error of the mean. We use mostly this value to calculate the 95% confidence interval. And if we want to do it, we can use the formula as 95% confidence interval, which is equal to the mu here is the mean of the sample, and it's plus and minus 1.96 multiplied by the standard error that we achieved from this formula here. And as you see, because we have plus and minus, we are going to have two values around the mean of the sample. Let's see how much it will be. If we put the numbers there and calculate, we reach to two numbers as 0.78 and 0.88. So we already have the mean of the population here, of the sample here, and mean of the population. We can guess that it will be somewhere between 0.78 and 0.88. So this calculation, this range that we have here is the interval. And if we say we are 95% secure or sure that sample, the population mean will be between these two numbers. I'm going to explain, say, where 1.96 come from. It's always the same factor, the same value. We are not changing this one. And if we want to explain this one, the 1.96, you remember when we had the mean in the middle, we had two standard deviation. We could go in two direction. So this is the standard deviation, one standard deviation, two standard deviation. And by this, the population, 95% of them is on this surface area. And we said that this two standard deviation covers the 95% of population. But in reality, actually, it's not two, it's 1.96 of the standard deviation. This is why we use this value here, which we can find the 95% confidence interval. One more time, we are 95% confidence that the population have the mean between 0.78 and 0.88 here. Also pay attention that the sample size become very important. When we have a bigger sample size, we have less error, less standard error. And when we have a smaller standard error, the total value that we have here will be a smaller, so we have a narrower confidence interval. And if this value standard error is increased based on the number of the sample, we have a wider confidence interval. A smaller or narrower confidence interval in this case means better estimation.